Hello guys, welcome back to my channel Code with Anish. So in the previous video we have developed this user authentication service and we tested as well. So we were able to finally generate an access token for the local user as well as the third party Google user. We were able to send the request from the postman to the user authentication service, and finally it returned the access token which was generated from the authorization application. Okay, so now we have the access token. So now we need to test this because we created this access token for the security purpose of microservice. So now we need to test this access token in a microservice. So for that we need a sample microservice. So in this video we will create a microservice and with some sample API inside it, and we'll test this access token to check whether we are able to access the microservice API using this access token, using a valid access token, and the microservice will reject those requests with the invalid access token or expired access token. Okay, so let's start creating a new project for microservice. So here we'll select a new project. We'll give name as a demo microservice. Fine. So in the POM we will add the parent dependency and 3.2.2. Now we will add the dependencies. So we need the starter web because it is a web application, so obviously we need the starter web. Then we need the starter security because we have to implement the Spring security to verify the token and grant the access. And then the OAuth2 resource server. This you have already seen in the user authentication service also. We are using this library, but there why we are using this, because we want to verify or validate the access token coming from the Google. So this library was used to verify that token and thereby authenticating the Google user and creating a token for that Google user as well. But here the same library, but now we have to verify the token generated from our user authentication service, which in turn from the authorization application. So here the JSON web key issuer will be our authorization application. So the code for that will be same as that of what we use in authentication service only to verify the token, but only thing is the issuer will change here. We will check the issuer for the authorization application issuer, which is currently running in our local host. Okay, so these three libraries enough as of now to start with our project. So we'll come to the main class. We will annotate Springboot application and Spring application dot run, and this main dot class, and fine, this is enough. And we will first configure the security configuration. So create a package, new package config, and here we will create a class security config. This is almost same as what we did for the user authentication service only. So here what we should give configuration annotation and enable web security. Now what, as we seen in the last video, we have to create a security filter chain. So at bean public security filter chain, you can name as filter chain, and the input will be HTTP security, and HTTP security dot build will give the, it will throw an exception, so it will add exception method signature. So this, now we need to add the configuration, or what we can say customization for this HTTP security. So first thing is HTTP security authorize HTTP request. So r dot any request should be authenticated. It's the first one. The next one is the authorization server, OAuth2 server. So here only the verification of the token take place, or whatever we configure here, this will take the responsibility of verifying the token with the JSON web key. So what we need an authentication manager resolver. Okay, so we need to create an authentication manager resolver here. So private, we can give JWT issuer authentication manager resolver and name the method as authentication manager resolver. So as we see, seen in the previous video, we have to provide a map of issuer URL with the JWK URL, and then map it to the authentication manager resolver. So maybe here we can make use of an application.yaml to save this issuer URL and the the JWK URL, because currently we are running in localhost, so the URL will be in the domain, the host name will be localhost. But if you are deploying some other environment, we cannot rely on localhost. We should use an appropriate domain name and all. So it may change. So maintaining an application.yaml, we can configure accordingly for different environment. So we'll create a new file, application.yaml, and here yes, so first we have to give the server port also. So since we are running locally, already 8080 is occupied by authorization application, 8081 is used by the user authentication service. So now here we can define 8082, and we'll put debug also true, so that we can see debug logs in the console. And now we coming to our authentication issuer and the JWK URL. So maybe we can create a property named OAuth and OAuth, and inside that we can create another key like JWTS. Okay, and let it be a list. So we'll give a hyphen, and it contains issuer URL and JWKS URL. So why I am creating as a list, this is because maybe in future if we have multiple issuer, we can add as a list rule, means we can keep on adding like this. We don't want to create a separate key and all. In the same key we can add as a list here, and that can be configured here, which I will show you now. So that's the purpose. I'm just sort of keeping this as a list here. So issuer URL is HTTP localhost 8080, and JWK's URL is localhost OAuth2 JWK. This we have seen in the previous video. So I'm substituting here. So now we have to access this property. So since we are using a property and a list chat, we can configure this in a Java class only. So it will be easy to refer this value anywhere using a Java class object. So here I can create a new Java class and name it as OAuth properties. OAuth properties. Okay, and configuration properties prefix. So prefix is nothing, this one. So that means whatever coming under this property will be loaded to the attributes defining inside this class. Keep private. So here we have only another property called JWTS, which is nothing list of these two values. So these two values should be now mapped inside a class. So for that we can create a class inside here in public SS. So public static class, and the class name we can give us JWT, and that contains two attributes. What are they? Issuer URL and JWCase URL. So in Java we will give us camel case, okay, and private string JWCase URL. That's done. Now here what we need is private list of what? JWT, and it is named as JWTS. So this JWTS holds the list of this JWT objects, which is issuer URL and JWTS URL. Okay, now we need the getter and setter, so obviously we'll go with Lombac library only. Okay, Lombok is added. Now we'll come and create the getters and setters. Getter and setter. Same for the inner class as well. And setter. So it will create the getters and setters of this thing. So with this configuration property annotation, these values will be injected here. Now to refer this class object or class bean, we need to inject this with at configuration as well, so that only bean will create Spring will create a bean for this class, and thereby it can be injected anywhere we want to use. So that's fine. So now the configuration, the Spring should create the bean. So now we can here auto where that private OAuth properties, and will give us OAuth properties. Okay, so now what we need? So we need a map of issuer and the JWT. So what do from this OAuth properties we will get JWTS, which is a list. Now we have to convert this to a map. So stream dot collect and what? Collect, not to list, to map. So in the map, what the first one will be j dot get issuer URL, and next one is what we need in the map. We need an authentication manager with the JWCase URL. An authentication manager only we need. So what we can create is another method which will actually create an authentication manager. So private authentication manager, create authentication manager here, and here what will come? String this one, JWCase URL. Okay, so now So here first we will create a decoder, JWT decoder. So decoder is equal to, we will use Nimbus JWT decoder dot with the JWK set URL, where we pass this JWK set URL and dot build. So this will create a decoder from the Nimbus JWT decoder class. Next, what we need is a JWT authentication provider. So JWT authentication provider. So provider is equal to new JWT authentication provider with the decoder. So this is how the flow is. So decoder will be set, decoder is provided to provider, and provide is then given to a provider manager. So return new provider manager with the provider. So basically provider manager is nothing which is an implementation of authentication. You can see provider manager is an implementation of authentication manager. So that's what we are giving here as the authentication manager needed for this authentication manager resolver. So that's how the flow is. A decoder. So decoder is what decodes a token. So while decoding the token, it uses the web key URL which we are setting here, which is nothing. In our case, it's a localhost only, the authorization applications web key that we set here, which is then given to a provider, and provider is set to the authentication manager, which is nothing, the provider manager. Okay, so now we can refer this here. So authentication manager, so J, and here what is it? J dot get JWK's URL. Okay, so what this will generate is, this will generate a map of string and authentication manager. That's the util map. So map is equal to this. Yeah, here what we can use is, we can use the method reference only instead of lambda, because we are referring to the arbitrary object, the arbitrary objects method only, so which can be replaced with the reference. So it's like OAuth properties JWT, making the code more readable. Yeah. Now what we need? Now what we need is, we need to return new JW authentication manager, and here as we seen in the previous video also, a customizer has to be returned. Customer is similar to the functional interface, where we can refer the method reference of this map which we created. Now to simplify more this, even if we don't want to have a variable here, we can take this whole line and put here, which will give in one line we can have the authentication manager resolver. So authentication manager resolver, which in turn has an authentication manager, and this is what we are setting here, authentication manager resolver. Okay, so we set the HTTP request or to the server, and as seen in the previous video, we have to set the session management s dot session creation policy stateless. Yeah, and also the course configuration dot course c dot course configuration. Yeah, so another method for the course configuration. So private course configuration source, configuration source. Configuration source, we will have course configuration. Course configuration is equal to new course configuration dot permit apply permit default values. So what are the default permitted values? They are allowed origin all, allowed method only some methods, allowed header is all. So allowed method is get, head and post. So the allowed origin and allowed origin and allowed head is it's already by default it is set as alt, so we don't want to give here. Only what we have to give here is the allowed method. So add allowed method is equal to the while character between all methods. Then what we need is course configuration dot set as post headers. So it's list dot of access control allow origin. Access control, that is as post header list. And then what we need is URL based course configuration source, that is equal to new URL based course configuration source, and course configuration source dot register course configuration. So here the path will give is all the path pattern, all the URL course should be allowed, and then the course configuration, that is what we have configured now. Fine, and return this course configuration source, which will now add here. Yeah, it's here, which we add here, course configuration source. So that's all the security side. Here we have defined the authentication manage resolver, where we have the JW's issuer and JWKS key set, which we set in the auth properties, which value is from application.yaml. Okay, security config is over. Now we have to create an API, which for that we have to create a controller. So we'll create a package, new package controller, and here we can name the controller as demo controller. Fine, and what will give us REST controller annotation and request mapping, and okay, so what we need to implement the controller. So here what I thought was like just giving a list of employees, because any example if you take in Google and you can see, right, employee class is something which is used across widely in the examples. So here also I will go with an API which return a list of employees. So let the API be request mapping be demo service employee, demo service employee, and yeah, so we are sending a list of employees. Then obviously we need a VO package VO, so we create a package VO, and there we define the classes, new Java class employee, and since it is a VO and it should be always final, instead of creating a final class we will go with the record only. So record value will be always final. Once it's created, then we cannot change it. So employee, what we give is employee, obviously employee name, then what, string the company where he's working, and finally I will say as designation. Okay, so that's fine. Now coming back to the controller, so we have to create a method here, public response entity, which returns employee. I will say list of employee. We will give list of employee, get employees. Okay, so list import class, fine, Java list get employee. To obvious, this method should be mapped with the get mapping. Fine, it is done. Now what we have to return is return new response entity, and here we should give list dot of elements, which we will create now, and http status dot okay. Okay, now coming here, list dot employee will give some 3 or 4 employees. Okay, so first employee, let it be, yeah, name. We can go global on this. Will depend some high personalities here. So let's first employee be Sundar Pichai, and what is his company? His company is Google, and what is his designation? CEO. Okay, so next employee, new employee. This can be Elon Musk. Okay, what is his company? Tesla, and designation obviously CEO. Then what, new employee? This can be Mark Zuckerberg. So what is his company? Meta, and designation CEO will be. And finally, one more employee. Let it be myself. So Anish, my company, Code with Anish, and my designation. I'm the architect and the typo in architect. Cool. So that's all. So by calling this API, it will return the list of employee. Fine. Now let's try to build this. So before building this, let's see, we haven't added the build plugin here. So we'll add the build plugin, and plugins, coming to plugin, group ID, org dot spring framework dot boot, and artifact Springboot, Maven plugin. Perfect. So let's reload it. Cool. Fine. We'll now add the Maven configuration. Maven, what is it? Clean and package. Yeah, okay. Before, okay, that's clean and package. Before running in that, we didn't give the final name also. So final name, it will be same as the artifact ID. So let's build and see if you are able to get a demo microservice.jar. Yeah, build successful. Fine, the jar is ready, and let me come to the application server 4080. So let's run this now. Edit configuration, Maven, add new Maven configuration, what, Springboot, run. Okay, apply. Okay, let's see if it is getting started. Okay, it started. Let's confirm the port where it started. Yeah, it's initialized in 8082 and it started in perfect. So port is also fine. Once again checking the security, it is also fine. Everything is done. Now we need to test it. So to test it, we'll use the Postman. Let's open the Postman. Okay, so the Postman is here. So I have already created an request for this demo microservice. So here, based upon the controller, demo service employee, it's there, and no body and only authorization. We need to add a bearer token. Okay, to get the bearer token, we need to call the authorization application. The actual flow is call user authentication service with username and password. It should go the authorization application, get the token. But for testing purpose, we can directly call the authorization application and get the token. So I need to start the authorization application locally here. Let me start it. My authorization application here. Let me start that application. Okay, it starts successfully. Let me generate the token then. Okay, the token is generated. We will use this here and see we are getting the employee list. Perfect. It is 200. Yeah. So we got this in the picture. Elon Musk, Mark Zuckerberg, and Anish. So we got the response successfully. And if you see here in the logs, it has called the JWKs of our authorization application, and it got the response successfully. Then only it has returned the response. Now let me decode this token, and I'm going to show you one thing. Okay, so if you decode the token here we have explicitly added the authorities as sole user. So if you have seen the previous video in that authorization application and authentication service, we are setting this as custom claim. Why we are adding this authority? This is because to make sure in the demo, in any microservice, based upon this authority only, it should give access to call certain APIs. That's the purpose of here. But we haven't handled this in this demo microservice. So we need to add that configuration so that we should test it whether based upon the authorities it is able to restrict any API or allow access to any API. Okay, so for that we have to come to the security config. So here in this authorized HTTP request, move this any request outside and dot request matches. And request matches, what we should give? We should give this API endpoint. So this API endpoint dot has authority. So here the authority returned by the token is role user. So we will put here role user. So that means to call this API, the user coming in the token or the user claims person in the token should have the authority as role user. So that's what this line means. But in addition to this, so if you have seen this authorities is set by us by a custom claim. It's not what a Springboot or the OAuth has given there. It is set by us. So by default, Spring Security or Springboot Security will check for a claim called scope inside that, and whatever value provided in the scope, that only it will consider as an authority. For example, if I have scope user, then it will be like the authority it will be checking is role underscore that user. But we haven't set the scope as this scope is something done by the framework, but we haven't done that. But why? Because we need a custom claim like authority to do that role thing, to authorize that. So how we can implement this is we have to come to this decoder part. Here is where the token is getting decoded. Here we have to handle that. We have to make the Springboot understand that you should check this field for the authorities in the claim. So to do that, we have to give the provider dot set JWK authentication converter, and here we have to define a converter. So we can go with the method private JWT authentication converter, okay, that's here, and JWK authentication converter is equal to new JWK authentication converter, and converter dot set JWT granted authorities converter. Why? Because we want to make now the Spring Security framework to understand that authorities comes not from, you should not check the scope field, you should check this authorities field. So it is a converter here. So which, if you see, use an interface which has two parameters. One is the JWT token, that is a request, and the granted other collection of granted authority is the return time. So here we will get JWT as the request. Okay, so JWT dot has claim. Okay, so maybe JWT here. Okay, so now if JWT dot has claim, what? This is the claim. If this claim is there, then get the, what was that? Get the collection of granted authority from there. Else, if it is not there, then this token is not valid. Our token, we expect the token should contain this. Then just throw new access denied exception. Yeah, fine. And the message is like authority is not found in the token. Fine. Now here what we do is jwt dot get claim a string list. Why? Because we have authorities coming the token as a list only, so we will take this as a string list. Then what we do, we stream it, and what we want to send this as a response, so return. So what should be the response here? It should be collection of granted authority. So now this is a stream of string, so now we have to give us a granted authority. So stream of string, which is authority. So new simple granted authority of A. Okay, now and collect that to collectors.list. Okay, here stream dot map. Map is convert from stream of string to stream of granted authority. Here why it is highlighting as issue, because here we are using arbitrary objects reference here, so we can change to the, it's not arbitrary objects, we are using a constructor reference here. So constructor, we are doing constructor, so we can change to a constructor reference instead of lambda. So yeah, so simple granted authority. So and then finally return the converter. So in a nutshell, what I can explain is this converter. Using this converter, we tell the Springboot security that please use this claim authorities to find the authority you're looking for. Don't look at the scope claim. That's all. And we add this to JWT authentication converter. So fine. So now we will stop and start it again. Get started. Now let's again trigger the employee. It's working fine. But now how will we make sure that this piece of code is actually working? The only way is you'll change the authority here. So now this demo microservice is expecting to call this API only the token or the user is the token which has the authority role admin, but our token has role user. So now if we start this with this change and call that API, it should not allow it. That's what you're expecting, because that token contains role user, but here we change the code to check if it is role admin. Okay, started. Let's see if it is going through or if it is restricting. What we expect is it should restrict. Perfect. Look, it has given 403 forbidden, and if you see the response, insufficient scope means it requires higher privilege, not role user, role admin. Perfect. So that means this is working. So this is one way. Now we can attain this. So this is, so each API we have to define here, each API or a pattern we can define like that. Similarly, what we can also do is, instead of defining here, we can go to the controller level method and also define it. For that, we have to define an annotation enable method security here. In addition to enable web security, enable method security, and then go to the controller, and here we have to give at pre-authorized annotation, and here we have to define same like what we had, has authority role user. Same thing we have to give here. Now here instead of double quotes, you have to give a single quote. Okay. So let's stop and start it again. So this is another approach of defining. So this is like each method we can annotate to check the PRS, or in a global level we can refer here, which will apply to whatever we are specifying here. Hello, let's test if it is working or not. Now it should allow because we have the role user. Yeah, to do a negative testing, we just I will change this to admin here and see if it is restricting that. It's not giving the access. Okay, let's test. Yeah, 403. Perfect. So These are the two ways. Either define there, I will change it back now. Either change it, you can add in the security config, or you can add in the each method level, each controller method level. Okay, so now we have tested the flow with a valid token and a token with a different authority. So authority wise, access wise check is also done. Now we can check with an invalid token and a spare token, because our final agenda is securing this microservice. So what all way the intruder or someone try to do something in the token and sending, we should restrict it. We should only allow valid token to call our API. So now we can test two more scenarios with an invalid token and a spare token. Okay, so let's change the code, everything now user, make it, and we'll start it. Fine, let me take an invalid token and test here. So I am using an invalid token. This invalid token sense, this is token which we used for the Google authentication. So same token. So that token should not work here because the issuer is different. This token is from Google, and our microservices expect only the authorization applications token, not from the third party provider. Yeah. Now if I send this, yes, you're getting unauthorized, and say, yeah, look, invalid issuer. The issuer is different. Okay, so this case is also passed. Now we can take an spare token from our authorization application and test it. Okay, now I got an spare token. Let me test with that. Okay, yeah. So here if you see invalid token, because while attempting to decode that, it spared. Okay, so all the negative scenarios, which are scenarios by which security can be breached, are tested, and well, our security framework has denied all that, and only with a valid token and valid unspared and has the appropriate authorities are allowed to access our microservice API. So with this session we covered this also. So we already covered authorization, user authentication, and now a microservice also. So we covered all these things. Now remaining is a web front-end application, which whatever we now did in the backend using Postman and all, now we'll create a web page, and there we'll have an option for the user to log in and sign in, and then we'll have an option to call this demo microservice, in this case the employee list, and list there. So that end-to-end flow from the UI we can cover in the next video, where we can cover the web page and do this end-to-end flow testing. So that's all for today's video. Thank you.